solve 3x cubed minus 12x equals 0. We're going to use the same method that we used before. We need to have 0 on one side and then completely factor the other side. So in this case, there's a greatest common factor. Both of these terms share a factor of 3 and x. So let's factor the 3x out of those two terms. First, divide to see what remains. So that first term, use the quotient rule, that'll be x squared. For the second term, that's going to leave 4. X will cancel out multiplicatively. So now we're left with this binomial, which can be factored because that is the difference of two perfect squares. So we'll have the sum and difference factors of the first term and the second term. So now any variable factor we set equal to 0 by the zero product property. So any factor containing a variable. So for our first factor, if we divide 3, we get x equals 0. That's one solution. For that second factor, if we subtract 2, we get x equals negative 2. That's two solutions. And the third factor, if we add 2 to both sides, x equals positive 2. So remember, the highest degree of the equation is the most number of solutions. It doesn't guarantee there'll be 3 solutions in this case, but there can be up to 3. Our next example, we want 0 on one side and completely factor the other side. So in this expression, there's a common factor of y. So let's factor that out and divide to see what remains. It's going to reduce each exponent of y by 1, which means the last one cancels out. And then we're left with this trinomial. We want to see if we can factor this completely. So factors of the first and last term, such that the sum of the products of those factors is the middle term. Actually, these are perfect squares. Do we have a perfect square trinomial? Same sign positive? Yep. But I'm not going to write it as a square because we don't know how to deal with that yet. I'm just going to write that same factor twice. Any factor that has a variable set equal to 0 by the zero product property. So y equals 0. Y plus 7 equals 0. We're going to subtract 7 from both sides. So that y equals a negative 7. And if we do the same thing with that third factor, it's the same factor, so we get the same answer. We don't need to write it twice. So we only have 2 solutions in this case, even though it's a third degree equation. Y equals 0 and negative 7. And the last example here, we want 0 on one side and completely factor the other side. So it looks like this is already factored because the exponent is 1. You know you're done. But this other factor has an exponent of 2. So let's see if we can factor the trinomial here. So factors of the first and last term that add up to the middle term there. So x squared's got to be x times x, and 3 is a prime number. So is 7. So it can either be 7 times 1 or 1 times 7. We'll see what works. We've got different signs. Bigger number is negative. And that works out there. So we already had an x plus 3 factor. Now this trinomial factors to 3x plus 1 and x minus 7. So any factor containing a variable will set equal to 0 by the zero product property. And then we'll solve those resulting equations. So if we opposite the number term, we get a negative 3. And if we opposite this number term and then divide by the coefficient, we get a negative 1/3. And opposite that number term from both sides, we get a positive 7. So 3 solutions here to this higher degree equation. And we can always check those solutions by plugging them back in for x and see if we get a true statement.